Alright, hi everyone. I'm back with the last few practice problems for Module 5 and maybe one extra problem at the end just to make sure. So we're going to start with practice problem number 6. It says how many moles of Cr, which, guess, chromium, atoms are in a 200.0 gram sample of chromium. Okay, so now I'm going to use a little math to convert here. So first I'll write down what I know. I know that I have 200.0 grams of chromium. Okay, then I'm going to look at my periodic table. I'll find chromium, Cr, right here, the first row of the transition metals, and I find that it has 52.0 as its atomic mass. So that means that I know it has 52.0 grams and 1 mole of chromium. I want to know in the question here how many moles of chromium I have here. So I'm going to use my my molar mass of chromium as a conversion factor. So I would say I have 1 mole in 52.0 grams of chromium. Now you can see I can cancel out my grams because this one's in the numerator, this one's in the denominator. So to find how many moles in the 200 gram sample, I just take 200 divided by 52, and what do I get? I don't have a calculator with me. I get 3.85 moles of chromium. Remember, the answer is very important to have the magnitude, the number, 3.85. What is the unit? Moles. And what is the chemical? Chromium. So make sure you have all 3 of those things in your good answer. Question number 7. How many moles of sodium hydrocarbonate, that's baking soda again, are in a 125 gram sample of the compound? Okay, so with number 7, I want to find, first of all, a way to convert from grams to moles. We know that's the molar mass. So when I have a big molecule like sodium hydrogen carbonate, I have to take each element in that compound and add up the information from the periodic table, the atomic mass, to get my molar mass. So I'll write down what I have. Sodium hydrogen carbonate. Then I'll look at the periodic table. Sodium has a molar mass of 23.0 grams per mole. So 23.0. Hydrogen has a molar mass of 1.01. Carbon has a molar mass of 12.0. Oxygen has a molar mass of 16.0. But I know I have 3 oxygens. 3 times 16, 48. And I add them up. Whenever I have hydrogen involved, I have something in the hundredths place, but significant figure-wise, everything else is in the tenths place, so I need to round to the tenths place when I add. So I find my molar mass of sodium hydrogen carbonate to be 84.0 grams in 1 mole. 1 mole of baking soda is going to have a mass on the scale of 84.0 grams. That's exactly what that means. But that's not all that I need to do for this question. It says how many moles of baking soda are in a 125 gram sample. Okay, so I have to convert grams to moles. So I write down what I know. I know I have 125 grams of baking soda. I know that 1 mole of baking soda would have a mass of 84.0 grams. I need to cancel out grams, so I'm going to use my molar mass, but upside down. I know just the same as 84.0 grams are in 1 mole, I know 1 mole has 84.0 grams of sodium hydrogen carbonate. So if I take 125 divided by 84, then I get, and here's my answer, 1.49 moles of sodium hydrogen carbonate. A nice complete answer right there. So I'll erase. Number 8 says, what is the mass of copper chloride if it contains 0.172 moles of copper chloride? Well, the first thing I want to do is find the mass of 1 mole of copper chloride, right? We'll use green, as you'll learn in a few modules. Copper looks green when you excite its electrons, which is always fun. I like copper salts a lot. Copper chloride is a salt of copper. Not something you have to know right now. What's the mass of copper chloride if it contains 0.172 moles of the compound? So if I want to convert from grams to moles, then I need to find the molar mass using the periodic table. Copper, so I look, I find copper. Make sure you remember and practice and memorize these chemical symbols over and over, even the ones that we already had the quiz on. You need to know them. Copper is Cu. It's here in the first row of transition metals, and it has a molar mass of 63.5 grams per mole. So 63.5 grams per mole. Then chlorine has a molar mass of 35.5 grams per mole. And of course you can see from the chemical formula there are 2 chlorines and 1 molecule of copper chloride. So we'll add it twice. So when I add them up, I find that copper chloride has a molar mass of 134.5 grams per mole. That means if I had 134.5 grams of copper chloride, I would have exactly 1 mole of copper chloride. So now I know also from the problem that I possess 0.172 moles of copper chloride. How do I convert that to grams? Well, I'll just use my mole ratio. And I find I have 134.5 grams to a mole from here. So that means I can cancel out my moles. If I multiply 0.172 times 134.5, I find that I have 23.1 grams of copper chloride. Alright, so number 9, how many grams are in 15 moles of Ce? So, if you look, you'll find Ce is cerium, I really hope. Maybe I'll look just to make sure, because it's really embarrassing to make a mistake on a video. Ce is cerium. That's good. And if I have 15 moles, I want to know how many grams I have. So I'll write down what I know. And I want to know how many grams that is. So I want to find out grams. I know that I can find on the periodic table if I look cerium. That's a GE. Oh, it's getting late. First one here in the, these are called lanthanides, you don't have to know that. But anyhow, molar mass of cerium is 140.1 grams per mole. So if I multiply 15 times 140.1, I would find that 15 moles of cerium would be, looks like 2.10 times 10 to the 3rd grams. Moles can cancel like that. And I use scientific notation here because I need to consider significant figures. So I have 3 significant figures here, I have 4 significant figures here. That means I can only keep 3 in my answer. Now if I wrote times 10 to the 3rd If I wrote 2,100 like that, it would only have 2 significant figures because these end zeros are not significant. So the only way to show 3 significant figures is to use scientific notation. And that's grams of cerium. So you want to make sure you tell me a number, a unit, grams, and what it is, cerium, CE, in your complete answer. So, let's see. Then our last problem, number 10, in the decomposition of 1.2 moles of dinitrogen pentoxide. So what is dinitrogen pentoxide? Well, dinitrogen, di means 2, pentoxide, penta means 5, so this is dinitrogen pentoxide. It is ionic or covalent. It's covalent because it has 2 nonmetals bonded together, which is why you use those prefixes when you talk about it. So, in the decomposition of 1.2 moles of dinitrogen pentoxide, how many moles of oxygen will be formed? Well, to find out something like this, we need a balanced chemical equation. We know when we have a decomposition reaction, we're going to break down a compound into its elements. I might erase this top one of them. Okay, so remember, important thing, that the homonuclear diatomics have to have their subscript. So now I need to balance my equation. Nitrogen looks good. Uh-oh, oxygen doesn't look so good. I know I need an even number of oxygens here, so I'll do this. 2 times 5 oxygens is 10 oxygens on each side. So I have 2 molecules of dinitrogen pentoxide decomposes into 2 molecules of nitrogen and 5 molecules of oxygen. And another way to say that would be 2 moles of dinitrogen pentoxide decomposes into 2 moles of nitrogen, which is a homonuclear diatomic, and 5 moles of oxygen, again, homonuclear diatomic. So, anyhow, the question asks me, if I decompose 1.2 moles of dinitrogen pentoxide, how many moles of oxygen would I produce? So I know I'd produce 5 moles of oxygen if I decompose 2 moles of dinitrogen pentoxide. So now I can use what I call a mole-to-mole ratio. So I look at what I want to know about. I look at the stoichiometric coefficients, the 5, 2, and 2 here, and I can try to figure out what I need to know. I know I have 1.2 moles of dinitrogen pentoxide. Now I want to convert this to moles of oxygen. We've been converting to grams, but you can use your balanced chemical equation to convert from moles to moles. So I want to cancel out moles of dinitrogen pentoxide. I want to end up with moles of oxygen. You can use the stoichiometric coefficients in a balanced equation just like a conversion factor. So I want to end up with moles of oxygen. I want to cancel out moles of dinitrogen pentoxide. So moles of dinitrogen pentoxide would cancel out here. I use my stoichiometric coefficients here. I say 1.2 times 5 divided by 2 equals, and I get, oops, up here. So I get 3.0 moles of oxygen. Now notice I have 2 significant figures here. My stoichiometric coefficients are perfect. You know that if you're dealing with atoms and molecules, you can't have a piece of an atom or a piece of a molecule. So these stoichiometric coefficients are perfect. Really, if we actually break down 2 molecules of dinitrogen pentoxide, we actually get 2 molecules of nitrogen, 2 molecules of oxygen. Or 5 molecules of oxygen. So those are perfect numbers. They don't have significant figures. They're perfect. So you only have to consider 2 significant figures here So you can have 2 here. 3.0 moles of oxygen are produced when you decompose 1.2 moles of dinitrogen pentoxide. One more just extra problem, just to make sure you understand. Before I give the answer to it, make sure you pause, try to work it out for yourself, and then restart the video. So let's see. What is the mass of a H2SO4 molecule in kilograms? Well, H2SO4 is sulfuric acid. That's what we used as a catalyst to decompose sugar last week when we had that big black mass coming out of the beaker. We want to know the mass of one molecule in kilograms. So, first thing I'm going to do is add up from the periodic table the atomic masses of each of these. Hydrogen, atomic mass is 1.01. I have 2 of them, so we'll put 2.02. Sulfur, I look at the periodic table, I find it to be 32.1 grams per mole, or atomic mass units per atom. And then oxygen, 16.0 is the molar mass, times 4 of them, that's 64. And if you think about it, okay, if you have 16 times 4, remember if you cut one in half and double the other, cutting 16 in half is 8, doubling 4 is 8. You know, 8 times 8 is 64, so 16 times 4 is 64. Makes you a little faster at math, which definitely helps me. Alright, so then we add up. I find my molar mass of one molecule of sulfuric acid to be 98.12. I have to round because all of my digits have to be significant in this place, so it's to the 100th. So what this tells me is one atom of sulfuric acid has a mass of 98.1 atomic mass units. 1 mole of sulfuric acid would have a molar mass of 98.1 grams per mole. What's my question? Okay, so I want to know what's the mass of one of those molecules in kilograms. So, if I have 98.1 atomic mass units for one atom, then I can look, and at the top of your test you'll find this conversion factor. 1 AMU is 1.66 times 10 to the negative 24 grams. So I want to find out grams and cancel out AMU. So I put 1.66 times 10 to the negative 24 grams per AMU. And that's 3 significant figures there. So I keep 3. Cross out my AMUs, now I know grams. But I want to know kilograms in this problem. I want to know how many kilograms one molecule of sulfuric acid would weigh. So then I'm going to cancel out grams. So I know I have 1 kilogram equal to 1,000 grams. And remember, with metric conversions, 1 kilogram and 1,000 grams, those are perfect numbers. You don't have to worry about significant figures. So significant figure-wise, I'm going to think I have 3 here, 3 here, 3 here. I can keep 3 in my answer. So when if you want to do 98 times 1.66 times 10 to the negative 24 divided by 1, which, you know, no big deal, times 1 divided by 1,000, and see what you get. When I do that, I get, let's see, 1.63 times 10 to the negative 22. Kilograms. Oh wait, that's kilograms. Okay. Ooh, negative 25. Sorry, it's late. My eyes are getting tired. 1.63 times 10 to the negative 25 kilograms is the mass of one molecule of sulfuric acid. My next question pertaining to this exact same molecule would be, so H2SO4, sulfuric acid. If you have 6.0 moles of sulfuric acid, how many grams would that be? So write down what you know, 6.0 moles of sulfuric acid. And how many grams would that be? So I know that there are 98.1 grams in a mole, so I can cancel out moles. 98.1 grams of sulfuric acid in 1 mole. So my moles cancel. I take 6.0 times 98.1. I can keep 2 significant figures because of this, and I find my answer to be 590 grams of sulfuric acid. And remembering every answer has 3 good parts: the 590, the unit, grams, and what it is, sulfuric acid, H2SO4 in this case. Since I only have 2 significant figures, 590 is perfectly valid. When you have 590, that really is 2 significant figures because the 0 in the end is not a significant figure. So, hope you are feeling more prepared for the test. Please call me, email with questions, and I hope that everyone stays safe during this storm, and I'll see you next week. Have a good day. Bye.